Hi, welcome back to another lesson. In this lesson, we will see the laws of vector addition and subtraction. We will see the different types of laws, and at the end, we will see vivid examples to help us understand them better. That said, let's get into class. The first law I want us to take a look at is the triangle law. Triangle law tells us that if I'm given a triangle ABC, like we can see, and I want to find this side AC, I have one of two choices. Either I go through the route A to C direct and find the side AC, or I can decide to go through the route A to B and B to C. That is, the side AC is the same thing as AB plus AC. Now, let's see the second law, that is the parallelogram law. Parallelogram law of vector addition tells us that the resultant of two vectors acting at a point can be represented by the diagonal of that parallelogram whose adjacent sides are the vectors. Take for example, in this parallelogram, I have two vectors B and vector A. Obviously, these two vectors form the adjacent sides of a parallelogram. From P to S has been tagged B. From Q to R can also be tagged B. They are equal. That is, PS is equals to QR. And at the same time, PQ is the same thing as SR. So that if PS is equals to B, QR will also be equals to B. And if PQ is equals to A, SR will also be equals to A. Now, the side PR obviously from this parallelogram will be equals to PQ plus QR. Now let's take an example. An example says that we should prove that the diagonals of a parallelogram bisect each other. That is, at this point, to prove that these lines bisect each other. If I call this line P on BD on AC, if I call this line P, this point P on AC, I want to call the same point Q on BD. Let's label the other side. My AD, I'll call that point B, and my AB, let me call it point what? Line D. Such that for line AC, such that we can see that AD is the same thing as BC, since it's a parallelogram, and will be the same thing as B. So I can call this B. And at the same time, AB will be the same thing as DC and is equals to D. So I can call this D. Now with this labeling, we can see that the vector at AC is the same thing as AB plus BC using our parallelogram law of vector addition. So that AC automatically will be the same thing as B, will be the same thing as D plus B. AP is half of AC. So that AP will be the same thing as half into D plus B. Also, looking at line BD, we can see that line BD is the same thing as BA plus AD. So that line BD will be the same thing as minus AB plus AD. This is AB. So that line BD, the vector at BD will be the same thing as minus D plus B. Now, if you look at BD, vector at line BD is the same thing as half, or sorry, now if you look at BQ is the same thing as half BD. So that this will be the same thing as half into minus D plus B. We've been able to define AP. I want us to define AQ. Now if you look at AQ is the same thing as AB plus BQ. So that AQ will be the same thing as AB. We defined AB to be D plus half into minus D plus B. Remember, we got PQ to be equals to half minus D plus B. So that AQ now is the same thing as D minus half D plus half B. AQ is the same thing as D minus half D, that is obviously half D plus half B, which is equals to half into D plus B. Now, we've been able to establish that both bisect each other. Why? Because AQ is equals to, let me make more space. Obviously, from our equation here, we have that AQ is equals to half B plus D. And also on our equation here, we have AQ is equals to half B plus D. So we've been able to show that AQ is equals to AP. So they bisect each other. In our next lesson, we'll see vectors and their components. Thank you for staying with us and have a nice day.